Hello and welcome. In this video I'm gonna show you some examples of using chain rule for finding derivatives of functions. Let me remind you what is the chain rule in simple words. Based on the chain rule, when you want to find derivative of any function, take derivative of the outside function and multiply it by derivative of the inside function. For example, suppose f of x is 2x to the power of 4 minus 3x to the 2 plus 7 to the power of 10. For finding the derivative of this function, to find f prime of x, first you have to take the derivative of the outside function. But what is outside function? If you pay attention, f of x is this bracket which is raised to the power of 10. So this bracket is the inside function and the outside function is the power 10. So for finding the derivative of this function, we have to find the derivative of the outside function based on the chain rule, and the outside function is power 10. So we need to remember the power rule to find the derivative of this function. What was the power rule? Let me remind you. If we have something like a to the power of 10 and we want to find its derivative, based on the power rule, the derivative is 10. We bring the power in front and we subtract the power by 1. The derivative of a to the 10 is 10a to the 9. This bracket here plays the role of a. So the derivative of this function is bring the power in front, so 10, then write whatever is inside the bracket and raise it to the power of 9. 10 minus 1 is 9. This is the derivative of outside function. Multiply this by derivative of inside function. What is inside? Inside is the bracket. So multiply this by derivative of the bracket. Derivative of 2x to the 4 is 8x to the 3. 4 times 2 is 8. We bring the power 4 in front. 4 times 2 is 8. We subtract power by 1. 4 minus 1 is 3. Derivative of negative 3x to the 2 is negative 6x, and the derivative of 7 is 0. You can put plus 7 plus 0 here, or you can write nothing because the derivative of 7 is 0. So the derivative of f of x is 10 times 2x to the 4 minus 3x to the 2 plus 7 to the 9 times by 8x to the 3 minus 6x. Let me show you another example. Suppose g of x is given by this equation: 1 over 3x plus 2 to the power of 5. If you want, you can find the derivative of this function right away with the quotient rule and chain rule. We need to use quotient rule and chain rule to find the derivative of this function. But if you pay attention, you can do something better. You can rewrite this function in a form that you don't need to use quotient rule at all. How we can do this? If we bring this expression from denominator to numerator, then we don't need to use quotient rule. So basically we can write this function in the form of 3x plus 2 to the power of negative 5. When we bring some expression to numerator, just we have to make its power negative. Now, instead of finding the derivative of this expression, we can find the derivative of this expression. Attention here, again, the power negative 5 is the outside and the bracket 3x plus 2 is the inside. And based on chain rule, for finding the derivative of this function, first we have to find the derivative of the outside function. We bring the power -5 in front and we write the inside, raise it to the power of -5 minus 1. So it would be -6. And then multiply this by derivative of inside. Derivative of the bracket 3x plus 2 is just 3. Because derivative of 3x is 3, derivative of 2 is 0, so derivative of inside is 3. This is derivative of that function. But if you want, because the original function is in the fraction form, it's not bad idea to rewrite your answer also in fraction form, but it's not necessary really to do so. Let me show you how you can do so. Here we have -5, here we have 3. Between these expressions, here is multiplication. If we multiply -5 by 3, it would be -15. So we have -15. This bracket is raised to the power of -6. We can move it down to the denominator and we can make its power positive. So it is basically 3x plus 2 to the power of 6. So derivative of this function is this. Let me show you another example. Suppose the function f of x is sine of cosine x. Can you figure out what is outside function and what is inside function? The outside function is sine because it covers the cosine x, which is inside that. So the cosine x is the inside and the sine is outside function. Let me remind you the derivatives of sine and cosine. If you remember, derivative of sine is cosine. Derivative of sine of x is cosine x. And in general, derivative of sine of any expression is cosine of that expression. But don't forget, if the inside here is not simply x, we have to multiply this by derivative of the inside. So you have to multiply it by derivative of whatever is here. And this is because of the chain rule. And this is what we are going to do here in this example. So remember, derivative of sine is cosine. And what is derivative of cosine? Derivative of cosine x is negative sine x. And if it is cosine of something, its derivative is negative sine of that thing. Again, don't forget, always you have to multiply by derivative of inside, derivative of this expression here. So you have to multiply by derivative of inside. Now that we remember derivative of sine and cosine, let's start doing this example. For finding derivative of f of x, first we have to take derivative of outside. The outside is sine. What is derivative of sine? Its derivative is cosine. So derivative of sine is cosine, and leave the inside by itself. So cosine of cosine x. Basically here we are using this formula. Derivative of sine of something is cosine of that thing. Derivative of sine of cosine x is cosine of cosine x. Now that we have found derivative of sine, we have to go to the inside and we have to multiply it by derivative of inside. What is derivative of inside? What is derivative of cosine x? Derivative of cosine x, look at here, is negative sine x. So multiply this by negative sine x. and this is derivative of that function. If you want, you can write this answer in this form as well. It's not bad idea to put the negative sine x in here first, and then multiply it by cosine of cosine x. And this is derivative of that function. Now let me show you another example. What is derivative of tangent x to the 2? First, always figure out the outside and inside function. What is outside? Tangent. What is inside? X to the 2. Again, let me remind you, derivative of tangent. Derivative of tangent x is secant to the 2x. But if it is tangent of something, its derivative is secant squared of that thing. But if this expression here is not simply x, it is a function for itself, then always you have to multiply it by derivative of inside. Don't forget. Sometimes students wonder when we have to use chain rule. Basically, you have to use chain rule for every derivative. When you want to find derivative of any function, you have to take derivative of outside and multiply by derivative of inside. So never you have to ask when I have to use chain rule. You have to use chain rule if you want to find derivative of any function. Let me explain you why basically you have to use chain rule for any example, any function, even if it is a simple function. Let's say we have x to the 4. If we want to find derivative of this, we know that derivative of this is bring the power 4 to the front and then subtract the power by 1, 4x to the 3. But basically, even here, you have to take derivative of inside. And derivative of inside is derivative of x. So what is derivative of x? It's 1. But because it is 1, never we take derivative of inside in simple case like this. But even if you use chain rule for this simple example, nothing changes. And your answer is the same. So always use chain rule even for simple functions to make sure that you are finding derivative correctly. Back to our question. What is derivative of tangent x to the 2? Derivative of tangent x to the 2 is secant squared of x to the 2. This box here is basically x to the 2. You have to multiply it by derivative of the box. Derivative of x to the 2 is 2x. So don't forget to multiply it by derivative of x to the 2, which is 2x. Again, if you want, it's not bad idea to write your answer in the form of 2x secant to the 2 x to the 2. Now let me show you another example. Suppose y is given by this equation 2x to the 3 plus 5. How we can find derivative of this function? Usually, for finding derivative of a square root of something, we write a square root in the power form. We write the radical as a power. We know that always we can write radical of something in the form of that thing to the power of 1/2. And why we do so? Because we want to use the power rule for finding derivative. After I finish this with the power rule, I will show you a better way for finding derivative of a square roots. But let's start with the power rule. So for finding y prime, based on the power rule, we have to bring the power 1/2 to the front, 2x to the 3 plus 5 to the power of 1/2 minus 1. 1/2 minus 1 is negative 1/2. Don't forget, it's not finish your derivative. You have to take derivative of inside. Always you have to find derivative of inside. Take derivative of outside function, multiply by derivative of inside function. What is derivative of the bracket? Derivative of 2x to the 3 is 6 x to the 2, and the derivative of 5 is 0. Attention, if you want, you can simplify your answer. If you attention, we can write this expression in this form. 6x to the 2, we keep it in numerator. This 1/2 is actually 1 over 2, so the 2 is in the denominator. And this bracket is raised to the power of negative 1/2. When the power is negative, we can bring the expression to the denominator and we can write it with the positive power. So we can write this as bracket 2x to the 3 plus 5 to the power of 1/2. Look at numerator. In numerator we have 6, in denominator we have 2. We can simplify that 6 with this 2, and we can write our answer in the form of x to the 2, 3x to the 2. And because this bracket has power 1/2, we can rewrite this again in the form of a radical. So we can write 2x to the 3 plus 5 to the 1/2 in the form of radical 2x to the 3 plus 5. But let me show you a better way for finding the derivative of square root functions, radical function, in a better way, in a faster way. Always, for finding the derivative of a radical, you can write it in a power form and you can do the derivative this way. But I recommend you that when you want to find the derivative of any radical expression, do it this way. The derivative of radical is 1 over 2 radical that expression. For example, if you have radical x, the derivative of radical x is 1 over 2 radical x. Of course, if you write this as x to the 1/2 and take the derivative with power rule, after simplification you can get same answer. But because we will see radical functions repeatedly in calculus, I recommend you to memorize it in this form. And don't forget, because the inside of the radical probably we have a function, don't forget to multiply your answer by derivative of inside, derivative of whatever is inside the radical. So for example, based on this formula, what is the derivative of, let's say, radical 3x plus 5? The derivative of that is 1 over 2 radical 3x plus 5 times by derivative of inside. What is the derivative of inside? Derivative of 3x plus 5 is 3. Now let's back to our question. We had radical 2x to the 3 plus 5. Let me rewrite the function here. We want to find the derivative of this function. If we use this formula for that, the derivative of radical 2x to the 3 plus 5 would be 1 over 2 radical 2x to the 3 plus 5 and multiplied by the derivative of inside. What is the derivative of inside? The derivative of 2x to the 3 is 6x to the 2. If you simplify 6 from numerator with 2 from denominator and you put 3x to the 2 in numerator, you can write this as 3x to the 2 over radical 2x to the 3 plus 5. If you compare this answer with this, you can see that they are same answers. Now let me show you another example. Consider this function y equals e to the power of 4x. This is exponential function. Let me remind you the formula that we have for the derivative of exponential functions. If we have e to the x, its derivative is e to the x. Now we want to learn the general formula for finding derivative of exponential functions in general. If we have e to any power, any exponent, derivative of e to any function inside this box, we can have any function. We can have 4x, 5x, sine x, cosine x, any complicated expression. Derivative of something like that would be like e to the x is e to the x, or e to the box is e to the box. If you memorize the formulas in this way, you can find derivatives easier. But don't forget, when we have a function here, this function plays the role of inside. Derivative of exponential function is itself, yes, like e to the x is e to the x. But we have to multiply it by derivative of inside. Inside here for exponential function is the exponent, so you have to multiply your answer by derivative of exponent. So don't forget to multiply by derivative of the exponent, derivative of the box. Let's use this formula for finding the derivative of this function. So in exponential form functions, the outside function is the exponential function. The inside function is whatever is here. Derivative of e to the 4x is e to the 4x. Derivative of exponential function e to something is itself, but you have to multiply it by derivative of inside. And derivative of inside, derivative of 4x is 4. So times it by 4. If you want, you can write it as 4 times e to the 4x. Now let me show you another similar question to this. Let's say we have e to the power of 3 cosine 2t. What is the derivative of this function? Derivative of e to something is itself, so e to the 3 cosine 2t. Don't forget to multiply by derivative of the exponent, derivative of whatever is here. Derivative of 3 cosine 2t. We want to find the derivative of this. For a moment, forget this coefficient here. What is the derivative of cosine? Derivative of cosine is negative sine. Derivative of cosine 2t is negative sine 2t. But we have this as inside. Derivative of 2t is 2. So derivative of cosine 2t is negative sine 2t times 2. But we had a 3 here. What we have to do with that 3? Of course, you have to multiply this by that 3. So derivative of 3 cosine 2t is negative 6. Attention, we have a negative, a 3 and 2. And between all of these is multiplication. So derivative of 3 cosine 2t is negative 6 sine 2t. So the derivative of exponent is negative 6 sine 2t. Maybe you wonder that should we use product rule here because we have something times by something? No, attention. The 3 here is a coefficient for this. So when you have a coefficient and number, keep the number, keep the constant, and take derivative of the actual function, the part that has variable. So always when we have a number, we keep the number, we keep the constant, and we take derivative of the rest. Derivative of cosine 2t is negative sine 2t times 2. Now we want to find the derivative of this function. G of x is given x to the 3 times e to the negative 4x. If we look at the function g, this function is the product of two functions, x to the 3, which is a simple function, and e to the negative 4x. And remember, derivative of something like e to the 4x is 4e to the 4x. but here we have e to the negative 4x. So which rules we need to use for finding the derivative of this function? First of all, definitely we need product rule, and also we need chain rule. Based on the product rule, when we have something like f times g and we want to find its derivative, the derivative is f prime times by g plus f times g prime. F prime is the derivative of the first function. What is the derivative of x to the 3? Its derivative is 3x to the 2 times by the second function, and keep it. Do not take the derivative of that. Then plus, write the first function, write the original first function, x to the 3, multiplied by the derivative of the second function, multiplied by g prime. In this example, g is this, and we have to multiply this by derivative of that. What is derivative of e to the negative 4x? Derivative of e to the negative 4x is e to the negative 4x times by derivative of the exponent. What is the derivative of exponent? What is the derivative of negative 4x? Negative 4. So the derivative of the given function is 3x to the 2 e to the negative 4x plus x to the 3 times e to the negative 4x times negative 4. It's not bad idea to write your answer in this form: 3x to the 2 e to the negative 4x minus 4x to the 3 e to the negative 4x. Now let me show you another example. Let's say f of u is given by this equation: u sine of pi u. What is f prime of u? Here, instead of variable x, the function f, the variable of function f is u. Nothing changes. You can behave u as x. For example, the derivative of x is 1, so the derivative of u is also 1. For finding the derivative of this function, again we need the product rule, because the function f is the product of two functions, u and sine of pi u. Derivative of u, like derivative of x, is 1 times by the second function plus write the first function multiply by derivative of the second function. Derivative of sine is cosine. Is this the complete answer? No, don't forget. Derivative of sine is cosine, but I told you, you have to consider and you have to keep chain rule forever. Whenever you want to find the derivative of any function, don't forget, take derivative of outside, multiply by derivative of inside. Inside the bracket we have something, we have pi times u. What is the derivative of pi u? The derivative of pi u is just pi. Pi u is like pi x. The name of the variable is just u. What is the derivative of pi x? Pi. Like what is the derivative of 3x? 3. What is the derivative of negative 2x? Negative 2. Because the derivative of x is 1, 1 times the coefficient gives us these answers. And if you want, you can rewrite this answer in the form of sine of pi u plus pi times u cosine pi u. Let me show you another example. We are given this function f of x is e to the power of ax times by cosine bx. What is the derivative of this function? For finding the derivative of this function, similar to the previous question, we need product rule because we have something times by another function, so we need the product rule. First, we have to find the derivative of e to the ax. Remember that the derivative of something like e to the 4x is e to the 4x times 4. So what is the derivative of e to the ax? A here is a constant, b is a constant, x is the variable. So when you want to find the derivative of e to the ax, you can keep it in your head like e to the 2x. How you find the derivative of e to the 2x? The derivative of any exponential function is itself, so the derivative of e to the ax is e to the ax. But don't forget to multiply by the derivative of exponent. The derivative of ax is a. So the derivative of the first function is e to the ax times a. Multiply this by the second function, cosine bx, plus write the first function and multiply by derivative of the second function. The derivative of cosine is negative sine. Multiply by derivative of inside. Derivative of cosine is negative sine. Yes, that's true, but derivative of inside, don't forget to take the derivative of the inside function. So the derivative of the given function is this expression. But let's write our answer in a better form. For example, it's not bad idea to bring this number to the front. So this is a e to the ax cosine bx, and we have this negative and b, so also let's bring those in front. So we have negative b e to the ax sine bx. Now look at these two functions and compare them. Let's say we have f of x equals cosine to the 3x, and another function is g of x cosine x to the 3. Is there any difference between these two functions? Definitely there is. One of them, this one, x is raised to the 3, and then we take cosine of that. So cosine of that expression. But here we have to calculate cosine x and then we raise it to the 3. Basically, this first function, the function f, we can write the f in this form as well. So this function is basically cosine x raised to the power of 3. And if you write this one in this form, then it's easier for you to find its derivative, because now you can figure out what is outside, what is inside, so you can use chain rule easier. Here we have a power outside and the cosine x is in the bracket, so it is inside. But in the second case, for function g, the inside is x to the 3, the cosine is the outside function. So as you can see, these two functions are completely different functions. So let's find f prime of x and g prime of x. For finding the derivative of f of x, first we have to use chain rule, and for chain rule we have to take the derivative from chain rule. We have to take the derivative of the outside function. What is the outside function? The power 3. So we need the power rule. We bring the power 3 to the front, so we have 3 times cosine x to the 2. And then multiplied by the derivative of inside, which is negative sine x. And if you want, you can write your answer in the form of negative 3 cosine x to the 2 sine x. But for finding g, derivative of g, the outside function is cosine, and derivative of cosine is negative of sine of what? The inside, leave the inside, times by derivative of inside, which is 3x to the 2. And if you want, you can write your answer in the form of negative 3x2 sine x to the third. I hope by watching this video you have learned how to use chain rule for finding derivatives of functions. Before I finish this video, let me remind you again that when you want to find derivative of any function, always you have to use chain rule, even for simple functions.